Okay, this is the first lab that we'll be doing, real lab we're going to be doing for this General Chemistry 2 series. And this has to deal with graphics. Now, I assume that all of you have had some graphing experience. In high school, you talked about graphs, made some graphs. I don't know whether you've used Excel or not. I go through a pretty detailed explanation in the lab I wrote up for you as to how to do a graph with Excel. If you still don't know how to do certain things, please email me. You got a week to do this lab. The earlier you get on it, then the earlier you can find out if you have problems, and then you can contact me and we can work those out. So basically the big ideas here for this lab in graphing, I'm assuming you know how to do some things, is the kind of graphs you need to do to get detailed information. When do we use graphs in chemistry? Typically you use graphs in science or whatever whenever you have a variable that is dependent upon another variable, right? We have the dependent variable and the independent variable, which always bothered me because the independent variable is the one that you can change, which means it's not really independent, but the one that they call the dependent variable is the one that is independent of your change based on the change of the other variable. Anyway, I know it confused me, and it doesn't anymore, but there's a response variable, and then there's the other variable, the independent variable. So if you make a graph correctly and do the least squares linear regression line, which Excel calls a trend line, that will give you an equation that will give you the mean response to 1 unit change in the independent variable. To get that correctly, you must make the right kind of graph. In this lab, you're going to be making 2 graphs, and then you're going to examine them and get some information about them. So if we're going to do a graph, we're going to have an X and a Y, and I'll talk about certain things that Excel does. You want to do a scatter plot, okay? First thing we want to do is a scatter plot, but there's several different kinds of scatter plots that Excel puts up there for you. You want to do the scatter plot where the data points are not connected, because we want the mean of the change. And if you do the connected lines and you do a trend line, I'm not positive, but I think Excel does the mean of the change of the average of the lines between the 2 points, and it messes everything up. So you want to do a scatter plot where you're going to get a series of dots like this, okay? Just a scatter. Then you're going to add a trend line. And that's going to give you the least squares linear regression line. And again, in high school, they probably taught you, well, if you want to get the slope of this, which is rise over run, yeah, it is. It's the mean of the rise over run. All you need is the last data point and the first data point. No, that's 100% totally incorrect. You can get the slope between those 2 points by taking the change in the rise divided by the change in the run of those 2 points. But you cannot get the mean of the change of all the points if you don't do a trend line, if you don't do a least squares linear regression line. So I know they told you, all you got to do is take the last point and the first point and minus them and then divide. That's utter hogwash. That only gives you between those 2 data points, and that's not the correct. That doesn't give you the mean. We want the mean of the response based on a 1 unit change in the independent variable. And to get that, we have to do the trend line. When you do the trend line, you're going to want to add the equation, which will come through as a y equals mx plus b. It'll be numbers in there. And then you also want to add the r squared value. Now, r squared is not the Pearson product moment correlation coefficient, which is r. That's what used to be used all the time, and that is actually used to create these graphs, but it's not what r squared is. R squared is actually the coefficient of determination, and it gives us the proportion of the change in the data is those dots, that is expressed in the model. The model is this least squares linear regression line. In other words, it tells us what proportion or percentage, you could think of, if you take it times 100, it gives you the percentage of that variation in the actual data, how it changes by increasing in response for 1 unit change in the independent variable. What proportion of that data is actually expressed in the model? So it tells you how good the model is for what you have. It gives you a lot more information, and if you're a chemistry major, chem majors, raise your hand. Well, you might change your mind by the end of the term. Chem majors, I'll see you later on in modern analytical chemistry, and I'll teach you all the statistics of this stuff that it really gives you a lot more information than that. So we want an R squared value. The closer R squared is to 1, okay, R squared is always 1. I know Pearson product moment correlation coefficient, you may have learned that before. You said, oh, it's closest to 1 or -1. Well, R squared is the square of that value, so it's always closest to 1. The closer it is to 1, the greater is the variation in the data covered by the model, and therefore the better the model is, and therefore the better that graph you got, the better information and predictability your plot will have. Now, sometimes students get all, concerned. Well, it's got to be 0.99. If you do real science, a lot of times, if you get an R squared value of 0.7, you're like ecstatic. This is how good it is, okay? So in real life, data has a lot more variation than you typically see in science classes because that's all contrived. So for ours, it's going to be pretty good. You want both those values because you will use both those values. The M here is the value before the X. X is the independent variable. That means for each value down here times this value plus this B, which is the y-intercept value, it's going to give you the y that is actually in the line. Not necessarily the y in your data, but the y in your line. The difference between the y in your data and the y from the line from this equation is called the error and residuals. And again, get into modern analytical, we'll go into all that. But that's what you want to do. You want to make a scatter plot. You want to make the scatter plot which just has the dots in it. That's one of the selections in there. You want to put in a linear trend line, okay? There'll be choices, but the default is linear. And then you want to add the equation and add the R squared into your chart, and you can put it up here on the top. Now, there's a couple things. One of the things is that Excel always puts this as 0. Always has the 0, 0 down here. So if you plot your data out, and your data is like way up here, you don't want a graph that looks like that. That just looks silly. So you want to change the axes so that the majority of the space in your graph is being used. So let's say this is 0, but really your stuff doesn't start up here till 37.5. Well, you can change this lower axis to start at 35 then, and go to whatever value it wants to go to with Excel. How do you do that? You double click on these numbers down here, and it should give you a selection to be able to change that. Same thing up here. Let's say your data doesn't start on the y-axis until you get to 17.9. Well, then we can set this to start at 15, right? That's going to cover it. So we change that and have it start at 15 down here. Now our data is going to be down here across the graph, and it's going to look much, much nicer, okay? Another thing is, occasionally you'll have somebody that'll tell you, well, you can always constrain it to make sure it goes through 0. Because technically, if your data technically should be 0 when there's 0, if there should be a 0 response when there's a 0 input, you can go ahead and constrain it through 0. Well, not necessarily. It's always better not to do that. And one of the reasons it's better not to do that is, imagine that my data is way up here, something like this. Okay? If I restrain it to go through 0, then it has to, let's say it was going to come down like this. Well, it can't. It's going to change the whole slope and make it go through 0. And you're putting a lot of weight, a lot of statistical weight on that 0 point when it's down there like that. So if your data is very close to 0 and technically it's supposed to, you could do that, but really you'd look at it and say, why doesn't it go through 0? Maybe there's some problem that makes it go so far off from 0. So it's very, very few times when you really want to restrict and force it to go through 0, although I know you may have been taught that. One of the biggest things about teaching college is that we have to overcome a lot of things that were taught to you possibly before that was not necessarily correct. There are times when you can constrain it through 0. That is something you can do. But generally, especially for science, most of the time you don't want to do that. So for this lab, please do not constrain it through 0, even though technically it would be 0, 0 should be one of the data points. It just biases the slope of the line, which is our mean response, the mean of the response to 1 unit change in the independent variable. So I think that pretty much covers everything that you need to do. You just need to make 2 plots, and you need to get a little bit of information and answer a couple of questions about them that are very, very simple. If you read the handout, it all should be covered in there. Typically, these videos are more like closer to 20, 25 minutes, but this one is such an easy lab. You'll have a week to do it. Remember, it's going to be due next week at the beginning of lab. I'll talk to you. I've already talked to you about that in the Zoom meeting that we had, even though we haven't done that yet in my time. All right. I think that's really everything that you need to know. If you have any questions, as always, make sure you email me, ask me. I can set up a Zoom meeting and we can go over stuff if we need to, or I can just answer it through an email. Makes it really, really easy. Okay, see you next week for next week's lab.